Guys, here, this is the section on 4.3 and 4.4 about different families and groups in the periodic table. So we're going to talk about metals initially and the physical properties of metals. And those include luster, that means the shininess of it, malleability, ductility, and conductivity. Malleability means how can we hammer it into a flat sheet. Ductility means can we pull it into a thin wire. And conductivity is talking about its ability to conduct heat and electricity. So good conductors of electrical current, these are characteristics of metals, and conductors of heat, they are usually shiny. They're usually pretty reactive with other substances. They corrode. A lot of times you've seen like cars that have been outside for a long time and they rust. They're bendable, again meaning malleable and ductile. You will need to know those terms, malleable and ductile. Hammered or rolled out into flat sheets, and ductile is pulled or drawn out into a long wire. And they're the largest group in the periodic table. And how does the reactivity of metals change across the periodic table? On the left-hand side, they're really, really reactive. And as you move towards the right, they become less reactive. So your most reactive metals are going to be found in the very first column on the left-hand side of the periodic table. That would be group 1 right here. And it's from lithium to francium, and those are called alkali metals. Notice how hydrogen is separate up here. They have some similar properties, but not all of them. So we're actually talking about lithium, which is here all the way down to the bottom. Those are the alkali metals, and they react with other elements by losing an electron. On group 2 of the periodic table, these are alkaline earth metals, or alkaline earth elements, and they're not as reactive, but still more reactive than most. Sorry, when we go back here to the transition metals, this group in the middle, this is where you're going to find gold and silver and things like that. It's a large group of metals, but it's not the most reactive group of metals. The group of metals over here, you notice that there's only 4 in group 13, 2, and then 1. These are the least reactive of our metals. And down here at the bottom, the lanthanides are found together in nature, and they're always combined with other elements. This is the group that's usually squeezed in around here on the periodic table. And then below that, the elements of the lanthanides are called the actinides, and they're so unstable that they only last for a fraction of a second after they're made. And you'll notice that some of the elements in this group, and actually here on the transition metals at the bottom, are man-made. So how are synthetic elements produced? Scientists make synthetic elements by forcing nuclear particles to crash together. This is an example of one of them, that's why it's highlighted. Properties of nonmetals and inert gases. Most nonmetals are poor conductors of electrical current. So if you think of sulfur, it's not going to conduct a lot. You don't think of it as a conductor. And most of them are not going to conduct well, and they're solid, metal, dull. Non-metal, I know you don't think of it this way, but sodium is a metal or to a non-metal. So non-metal is an element that lacks the properties of the diatomic molecule, and this is just term you should know, is when 2 atoms, so we have N2 or O2, that's a diatomic model. Halogen is going to be group 17, the second to last group. It contains fluorine, chlorine, bromine, iodine, and acetane. And those are all salts. Inert gases do not ordinarily form compounds, and that's the very right-hand column. Semimetals have some properties that are typical of nonmetals, and a semiconductor means that it conducts electricity and currents under certain circumstances. Metals are conductors. This is like a silicon chip that you find in your computer. We want it to conduct necessarily heat. And the nonmetals here, as you can see, as you look down the column, you're going to use that are non-metal here. These are semi-metals, and then these are considered metals. They can gain, lose, or share 4 electrons in the carbon family. And we're looking at the nitrogen family here. Nitrogen and phosphorus are the only 2 non-metals in that group. These are the semis, and this is a metal. And they usually gain or share 3 electrons when reacting. oxygen family. These three are considered nonmetals, and they gain or share 2 electrons. And the halogen family here, these are all considered nonmetals. At the bottom, that's a semimetal, and they gain, or they share or gain 1 electron when reacting with other elements. Now this is the inert gases, also known as the noble gases, and they are usually found on their own. They don't gain, share, or lose electrons with anything. And because hydrogen, I mentioned before, are so different, it's really not grouped into a family. And so how are these semimetals useful? So their ability to conduct electrical current makes them really useful in certain circumstances. Now I want you to go ahead and go to this URL. Notice that this number right here, it's a 0 at the end. I put it in the directions, and answer the questions from the flip lesson. Thanks.